This is Annam. She is an engineering student and was wondering whether series resistor connections are better or parallel. No matter the combination or complexity of the resistor network, all resistors adhere to the same fundamental principles as outlined by Ohm's law and Kirchhoff's circuit laws. Resistors in series or parallel resistor networks can be substituted by a single equivalent resistor, REQ. So, she first connected two resistors in series, examined them and calculated R equivalent. When two or more resistors are linked up together in a way that a common current flows through them, the resistors are said to be connected in series. In series circuit, current in all the resistors remain constant whereas the voltage is different for each resistor. Therefore, series circuits are classed as voltage dividers. Here, we have two different resistors, so we can write V is equal to V1 plus V2 from Ohm's law. We know V is equal to I into R. Equation 1 becomes I into R equals I1 R1 plus I2 R2. As I1 is equal to I2 is equal to total current I, we can write IR is equal to IR1 plus IR2. Take I common, IR equals I into R1 plus R2. Current on both sides gets cancelled. An equation of resistance is obtained as R equals R1 plus R2. Hence total resistance in a series circuit is the sum of all the resistors connected. R equivalent is equal to R1 plus R2 plus R3 up to Rn. N is the number of resistors connected. Note: total resistance is greater than the larger resistance of the circuit because individual resistances are adding.
Oops, what is this? One of the resistor has burnt and my circuit is not working anymore.
What should I do now?
She found out that the problem with series circuit is, if any of the resistors breaks down or doesn't function properly due to any reason, the whole circuit stops working because there is only one path for current to flow. As soon as circuit becomes open, closed loop path vanishes and circuit breaks down. Like if we have connected a lamp and a fan in series combination. If the fault occurs in lamp, then fan will also be switched off. If fault appears in the fan, then lamp will also be switched off. So what should we do when one of the appliances doesn't work? The answer is parallel circuit combination. Parallel resistors. The supply current may not stream in the same manner through every branch of the parallel network since there are numerous paths for it to take. However, in a parallel resistive network, the voltage drop across each resistor is same. All parallel connected elements, including resistors, have a common voltage applied across them. Therefore, parallel circuits are classed as current dividers. Supply voltage is equal to V1 is equal to V2 volts. Total equals V1 equals V2. Total current is the sum of currents in each branch. I is equal to I1 plus I2 from Ohm's law. We can write equation 2 as V over R equals V1 over R1 plus V2 over R2 as V1 equals V2 equals V. From equation 1 we replace V1 and V2 by V over R equals V over R1 plus V over R2. V common V over R equals V into 1 over R1 plus 1 over R2. V on both sides gets cancelled. Equivalent resistance is obtained as 1 over R equivalent is equal to 1 over R1 plus 1 over R2 up to 1 over Rn resistors, where N is the number of resistors connected in parallel. Hence, the inverse of the equivalent resistance of two or more resistors connected in parallel is the algebraic sum of the inverses of the individual resistances. Note that the equivalent resistance is always less than the smallest resistor in the parallel network, so the total resistance, RT, will always decrease as additional parallel resistors are added. If the two resistances in parallel are equal and of the same value, then the total or equivalent resistance, REQ, is equal to half the value of one resistor. That is, REQ is equal to R over 2 for two parallel resistors. And for three equal resistors in parallel, R over 3, etc. Note that the equivalent resistance is always less than the smallest resistor in the parallel network, therefore the total resistance, RT, will always decrease as additional parallel resistors are added. The value obtained from parallel resistance is represented by the term conductance, denoted by the symbol G, and its units, the Siemens, denoted by the sign S. Resistance's inverse or reciprocal is conductance G equals 1 over R. We must take the reciprocal of the conductance to obtain the equivalent resistance, REQ, of the parallel resistors, in order to convert conductance back into a resistance value. series connection is simple and can be created using a single method, but parallel resistor network can be created using different combinations. Let us have a look on other forms of parallel network. The following figures show different forms of parallel networks. Now let's discuss the practical uses, advantages and disadvantages of each type of resistor combination. Applications of resistors in series. Number 1. Resistors in series can be used to generate various voltages across themselves, and this kind of resistor network is quite helpful for creating a voltage divider network. Number 2. Electrical equipment frequently and extensively uses series circuit connections. Number 3. Small radios often have their tube filaments in series. Number 4. A current controlling device which is protecting is always connected in series. Number 5. Automatic house heating equipment has a thermostat, electromagnetic coils and safety cutouts connected in series with a power source, etc. Number 6. Fuses are connected in series with the device they protect. Application of parallel resistor combination. The use of parallel circuit connections is extremely common. In order to allow for autonomous operation of each lamp or electrical appliance, multiple lamps and appliances are linked in parallel in our homes. The lamps or loads must be wired in parallel for us to be able to regulate them. Advantages and disadvantages of series combination. Advantages. It is simple to turn on and off all connected appliances. It is safe because less current travels in the circuit. It is utilized when a large number of bulbs are to be employed at once. Example, Independence Day decoration. Disadvantages. Each appliance has a single switch, making it impossible to turn them on or off individually. All other appliances will cease to function if one stops operating for any reason. Because resistors divide the voltage, not all appliances receive the same voltage. As a result of excessive equivalent resistance, the amount of current flowing becomes exceedingly slow. Advantages and disadvantages of parallel combination. Advantages. All other electrical devices continue operating even if one electrical device stops working for some reason. Each device can be individually turned on or off. The power supply line's voltage is the same for every electrical appliance. Devices can use more current to operate because the overall resistance of the circuit decreases. Disadvantages. If thousands of devices need to be used simultaneously, this process becomes tedious. As more current flows through the circuit, the safety decreases. Anam is now happy and relaxed as she knows there are advantages and disadvantages of both combinations, so we use the one as per our requirement or depending upon the application. In real world, combination of both series and parallel networks are used.